Hi, welcome back. We are at ISRO previous year questions, induction machines. I have already discussed some questions. Now we're continuing the session. Okay. And the last session, we got a nice participation from all of you. I want you to participate in the similar way. You'll get a question on the screen and you need to answer it. Okay. Just give them the options in the chat A, B, C, D, what are the options you feel like to just give it, then I'll explain. Let's start with the first question. Are you ready? Give it a thumbs up. Give it a thumbs up. Ready for the first question? Boom. Here we go.
The first step towards achieving your dreams is having the right coach. Get the best education with PiSquare Academy and make your gate electrical dreams come true. Download the app now.
Yeah, easy one. We got answer. We got answer. Thirty seconds more. And Sampath he has given explanation also, a bit of explanation. I understand what kind of explanation he's trying to give. I got an explanation, Sampath. Anyways, so people are saying only Raju has answered C, 5.3 high. So let's see, using the relation as Sampath is saying, let's use a relation. See, you can quickly use a relation and try to guess Sampath. I think you guessed it right. The powerful relation. The powerful relation in case of induction motor is PG, which is rotor power input, PCU, and mechanical power developed. This is 1 is to S is to 1 minus S. This is the most powerful equation. Okay. So in this it is asked for copper losses are given. Copper losses are given as how much? 5 kW. It is asked for PG. Okay. And you need to find the slip value. You need to find the slip value. What is the slip value? Slip is NS is equal to, how much is NS? 1000 RPM. See, I'm not calculating NS because 6 pole 50 hertz means being electrical engineer, you should know it's 1000 RPM. Okay. If you want to calculate, you go by 120 F by P. And with the practice of questions, keep practicing questions. Then automatically, these numbers, 1000, 1500, all these things will be there in your head. If you don't have a practice, it's gone. You have to have a practice. With the practice, they will be in your head. So NS is 1000, NR is given as 950. So slip is equal to 50. I'm just directly writing it because I know 1000 minus 950, I mean, will give us 50. So that's why 50 by 1000. Okay, you can do that. So you're getting slip as 0.05. 0.05 is the slip. So with that, let's just put in the formula. PG by 1 is equal to, or PG by PCU is equal to 1 by S. I know the value of PCU. I just want the value of PG. So PG is equal to, PG is what? Rotor input power. Copper losses is 5 kilo by 0.05, which is a slip. Okay, 5 kilo by 0.05. If you do that, you will get answer as 100. You'll get answer as 100. Raju, I don't know how we got option C. It is 100 kilowatt. 100 kilowatt. Okay. I think you must have given as mechanical power. Mechanical power developed is 95 kilowatts, but it is asked for a rotor input power, which is 100. I hope you got a clarity. Give it a thumbs up. Give it a thumbs up if you got a clarity of what I'm saying. Give it a thumbs up. Got it? Okay. Next question. We shall move to the next question. It's looking a little bigger, but it's an easy one. Okay. Looking bigger, but simple to answer. This is once again easy question. We don't require much of time for this. Easy one. I told you these characteristics are very important. Torque slip characteristics. You should be able to draw quickly the torque slip characteristics. Okay. So what is said here? It is said constant V by F ratio. Constant V by F ratio. If the frequency is decreased below its base value means rated value. Okay, below its rated value, if frequency is reduced, and obviously voltage has to be reduced proportionally because V by F is constant. Okay, and which is fed to an induction motor. So he's trying to say in this entire statement, it just V by F maintaining constant. That's the only statement he want to make from these three lines. And its starting torque and peak torque for direct question from the family of curves. Torque slip characteristic curve. Okay, direct question. If you just draw the torque slip characteristics in the part 1 of induction motor also we have seen similar question. Okay, so that will be something like, suppose at rated frequency and rated voltage, if it is like this, if frequency is decreasing, then starting torque will go up, but maximum torque will be same. For the decreasing frequency will be like this. For V by F ratio constant, you will get these curves. Okay, for V by F ratio constant. So starting torque is increasing. Okay, this is a decrease in frequency. Decrease in frequency curves are like this. And maximum torque is maintained constant. Okay, so option B, Raju is absolutely right. Rajesh is opting for A, Datri is opting for A. Both starting torque and peak torque remains the same. No, starting torque, peak torque, they won't remain the same. Okay. Anyways, I think you got it. You got it. Just give it in the chat. Give it in the chat. You understood what I'm trying to say? Shall I move to the next question? Next one. Try this. Yeah, this is something interesting question. Try answering it. It's not that easy. ISRO 2014 question. I think question, for the goodness of the question. Give it a thumbs up for the goodness of the question. Really good one. Raju, Sampath, any tries? At least think something. Think and attempt. And again, like a previous session, we'll have some winners in this session as well. We'll be having winner wheel is there. We'll spin that wheel. For that, to get the eligibility to that spinning wheel, you have to participate in the chat. Okay, if you're not participating in the chat, you will not get a chance to win. Okay, participate in the chat so that you'll get a chance to win. Anyways, time's up. So let me explain what is the concept of what's the concept behind this question. Simple one, but interesting one. Let's see that. It is said a voltage source inverter, okay, voltage source inverter VSI, is used to control the speed of three-phase 50 Hertz squirrel cage induction motor. Okay, don't look at this lengthy question. Don't get afraid of lengthy question, because it is said VSI is used to control the induction motor, speed control purpose. That's it. And it is a 50 Hertz, and its slip value is 4. That's what the only information what we got so far. 0.04 is a slip, and frequency is 50 Hertz. This is what is given. Okay, so from this quickly you can find out what is the rotor frequency. Rotor frequency is what? Quickly tell me in the chat. What is the rotor frequency? I'll move to the next part. So I'll just see your chat. What's the rotor frequency? Tell me. And it is said the flux is maintained at a rated value. Flux is maintained at a rated value, and you're connecting an inverter, means he's trying to say, with this line, he's trying to say V by F is constant. That's what he's trying to say. V by F is constant. Yes, Datri, you're absolutely right. Frequency, rotor frequency is equal to, yes, Ashrit, you're absolutely right, 2 Hertz. Okay, formula is S into Fs. So S into Fs, if you do it, you will get rotor frequency as 2 Hertz. Okay, and it is said if the rotor frequency, V by F is constant. With this line, you understood V by F is constant. That's what. First couple of lines, first 5 lines, what they're trying to say? They're trying to simply say it's a V by F control method, and rotor frequency is 2 Hertz. Okay, that's it. That's all about this first 4 lines. Okay, and if the stator resistance and rotor losses are neglected, that's what trying to make you at comfort zone. We take that approximation, forgetting the losses, ignoring the losses. Then this comes the real question. So what should be the impressed voltage frequency? Because options are given in terms of frequency. So the input voltage frequency should be how much I should give at the input, careful, to obtain that twice the rated torque. Suppose when I'm operating, I got some rated torque we are getting, okay, some torque we are getting at particular percent of slip, particular value of slip, I'm getting some torque. Now I want the same torque, not same torque, I want the double torque. I want the double torque at the starting. Okay, if you want the same torque at the starting itself, I want same torque at the starting, and it is a V by F control method. When you're trying to control by V by F method, what will happen? This curve will be shifting. This curve will be shifting like this. This curve will be shifting like this for decreasing value of V by F. Okay, and this is a load torque which is constant. Let's say this is a load torque constant. Okay, and at one value of V by F, maybe you will get a torque slip characteristic, something like this. Okay, torque slip characteristic is something like this. Now what I said, the question says, I want to attain the starting torque, double the starting torque, double the rated torque at the starting itself. when nr is equal to 0. When nr is equal to 0, I want the double torque. So here, slip value is something, suppose. It's not matter here, slip value, slip frequency, FR, rotor frequency, suppose something. Okay. Now, if speed increases, speed is increasing, slip frequency is decreasing. Slip frequency is decreasing, you can see from this. And the torque is decreasing. The torque developed by the motor is decreasing. You can see the curves clearly, pretty clearly. You can see all the curves. Okay. As speed increasing, frequency is decreasing, rotor frequency, I mean. And accordingly, the torque developed is decreasing. Okay. Means to reduce the torque, rotor frequency must be less. And this relation is a proportional relation because in this region, it is a linear relation. Torque and slip, they are proportional. Okay. So I want to double the torque. So rotor frequency must be double. Okay. Because if torque reduces means what? Rotor frequency is reduced. If you want more torque, give more rotor frequency. Okay. And see, you're not giving input voltage to the rotor, rather you're giving voltage to the stator. Here the logic, very good question. Here the logic is, when it is at stationary, at starting it is said, it is at stationary, rotor frequency and stator frequency, they are just the same. Okay. So you give at stator 4 hertz, in the rotor also you'll get the same 4 hertz frequency because it is the starting. Okay. This is something really interesting question. I don't know if you got it. It's good. Otherwise, in the maybe broadcast after the live is over, just watch this session, this part once again. You will get a much better clarity on this because there is a good key elements involved in this question. Good concept is involved in this question. Okay. Anyways, I'm moving to the next question with this. Just tell me if you have anything on this to ask. If you have anything on this to ask, you just ask me. Otherwise, I'll move to the next one. Give it a thumbs up. Press that heart symbol there. Yes. Shall move? Okay. I'm moving to the next question. Yeah, I want you to respond in the chat, because if you respond in the chat, then only that AI will pick you in that winning wheel. Okay. You'll get a chance to win our courses. Hi, Praveen. Hi. Praveen. We got an answer from somebody. Raju is saying C. Ashrit is saying D. Easy one. Concept, again, there is something interesting concept involved here. Okay, very interesting question. Very interesting aspect is involved. Try. People are saying C, D. Anyways, let me explain this. Here, concept is key here. Okay, let's focus on the concept, what he's trying to ask. This could be one of your interview questions also. It's not just MCQs. Mock interviews recently happened. There are a lot of students, we conducted some of the mock interviews to our students. And then we got some questions also in Mumbai. They got some questions, and these could be one of the questions. These are one of the questions rather, and this could be your interview question also. Okay. The question is, look at this. A three-phase induction motor is there and it is running at 1440 rpm. 1440 rpm it is rotating it, and when supply rated voltage is given to the motor. Okay. Here, not just the answer, focus on the analysis. Focus on the analysis also. And when fuse of one phase gets burned, fuse of one phase gets burned, can you just name this condition? What is this condition is called? I just wanted to see the name. I just wanted to see the name. So this is called as some condition in technical terms. What is that condition? I mean, this phenomena, what is occurred is named as something. Just name what is that. Yeah, they'll not give you these much of details. Yes, Raju, you're right. Yes, Raju, you're right. It's not a Praveen single phase, it is single phasing. Okay, what is that? Single phasing. Very good. Now, Ashrit is trying to say something. Ashrit is trying to say, sir, open delta. Okay, let's understand his point as well. What is this open delta? I mean to say, in the question it is not said whether it is a star connection or delta connection. Okay, whether it is star connection or delta connection, it is not said. So first thing, so if it is a star, something different. If it is a delta, something different. You have to analyze all the cases. Okay, if it is delta, Ashrit is absolutely right. If it is a delta, it will work, it will continue to run almost close to the same speed, 1440 speed, okay, in open delta configuration. But it will not be able to take such a load what it was taking earlier. It will be able to take less load, like open delta transformer, absolutely right. Okay, so it will be able to run at the almost same speed, but almost same speed, not at 1440 speed, little less speed. Okay, and it will be able to drive little less maximum load. Okay, if it is a delta connection. If it is star connection, the drop in speed is much higher. I mean, speed will be reduced significantly. Okay, and also you will see noise, a lot of noise. So these are the aspects, but it will continue to run. It will continue to run. So single phasing means one phase getting burned is called as single phasing. Okay, if one phase is burned, whether it is a star connection or delta connection, it will continue to run. If not at the same speed, little less speed. Okay, so what is the less speed here? 1440, less than 1440 is, we have two options. One is 0, another one is 1380. So it will not be 0, means motor will not stop. It will be at reduced speed. Sir, will the manufacturer consider every parameter or they will neglect some losses while designing? See, we are the guys, for the analysis purpose, we keep neglecting the losses and all. Okay, for the analysis purpose, because we are engineers, we're not scientists, right? What's the difference between scientist and engineer? That's what I always used to say. What's the difference? Can you just tell me? What's the difference between a scientist and engineer? Scientists will not take any assumptions. They don't want any ease of their mathematics or anything. But we engineers want the things to be done in an easy way. Means we take a lot of approximations. Of course, with that approximations, there will be a slight deviation in the result, but we don't care about that slight deviation. We're not worried about those slight deviations, but what we worry about is great advantage, what we'll be getting. The advantage is what? The advantage is I don't have to do a lot of mathematics if I take that approximation. Okay, so we take approximations, but not as a designer, they should not be. Okay, they will have to take everything. They'll have to consider every parameter. I hope you got the point. Did you get the difference between engineer and scientist? Give it a thumbs up. Who is engineer? Who is scientist? You got something? Yes. Hit that. Okay. What you guys are doing? Hit that hard. Yes. Sir, it will run below 1440. Absolutely right. Sampath, Ashrit. I think Raju, is your question answered? Shall I move to the next question? Good. Next question. Good. Yep. Let's see Who is going to answer this first? I want everybody's participation because if you participate more, I told you, right, there is a chance for you to win. Something is for you. I think that's pretty much good enough time because it's a theoretical question, right? Theoretical question. I'll get to your questions from the chat. I'll take the questions in the chat, but let me just finish this question. This question, let me finish it. The question says the circle diagram. Careful, guys. Circle diagram. You can frame a lot of questions, very interesting questions from this circle diagram because the concept behind the circle diagram is amazing. And your interviews, you could get some good questions. You'll get a chance to impress your interviewer if you know properly about the circle diagram. Okay, let's see what is that circle diagram, and we'll discuss this cycle diagram only for three-phase induction motor. Why we'll only discuss about three-phase induction motor cycle diagram? Why not for other machines? Why not for transform? Why not for synchronous? That could be, interesting questions can be framed based on that. Now, the diameter of the circle is determined by the total stator current. No, circle diameter, if you see, when you're framing the circle diagram, this is what I naught, and here you'll be keeping I2 referred to primary. I2 referred to primary. So accordingly, we'll just draw this circle. Okay, so this diameter is the rotor current referred to the stator. Rotor current referred to the stator, not just even rotor current. Rotor current when referred to the stator. That's what the diameter of the circle. Okay, so option is C. Only Ashrita said right answer. It's not total stator current. Total stator current could be what? It is nothing but if you add this I0 to this I2, that's what total stator current. But here, the diameter of the circle is just this. Just focus, Raju. So Ashrit is right for this. Okay. Now we got a question from Govind. Govind is saying, so if there is no protection, means he's trying to ask this question for the previous question. Single phasing concept. Single phasing concept, yes, motor will burn when? If you are maintaining same load, because it cannot obviously take the same load. But if you keep applying same load, even though one phase is out, then obviously most motor will burn. But in the previous question, it was not mentioned anything about the load, so it will not burn. You cannot say that. And there is one more interesting point, what is said by Sampath. Sampath, he was saying in the chat, RMS will still produce. Sampath, I think slight correction. You're trying to say maybe RMF, rotating magnetic field. And we have a beautiful animated video on creation of RMF, rotating magnetic field. And to say a point, you're absolutely right. Yes, RMF will still produce. Yeah, Sampath, yes, you're absolutely right. RMF will still produce, but not with a constant speed and not with a constant magnitude. Okay, if you have two phases are balanced, means 90 degrees displaced, then you will get a RMF with a constant speed and constant magnitude. But for the previous case, yes, RMF will produce, and to get that details, check RMF video in the PiSquare channel, you will get a nice animated video on that. Then, and I must recommend to all of you guys to watch that RMF concept. Okay, that's one of our popular videos. Yes, so Ashrita has already watched it. You felt RMF because we have developed an experiment also. One experiment also, two videos actually were there. One is experimental video, another is animation video. Okay, both of you can feel it like the way Ashrita is feeling. Okay, so see, that's what the beauty behind the AC machines. That's what the beauty behind. That's what the imagination behind the Nikola Tesla. Unless you don't feel it, I mean, there is no point of learning electrical engineering at all. You feel what Tesla is feeling, then you will see the beauty of AC machines. You're gonna love AC machines. Okay, because the key is lying over there. RMF concept. I'm moving to the next question with this. I hope all your questions are clear. If it is clear, give it a thumbs up. Press that heart. Pump some blood into the heart. So the moment you see a linear induction motor, don't panic. You don't have to get panic by looking at a linear induction motor. What is that? The concept behind, of course, you might have not learned, you might have not studied linear induction motor, but you know what is a rotatory induction motor. And the same concept is applied over here also, nothing big thing here. Okay, so we already got some answers. Now let's see. Thrust. See there, if it is a rotational induction motor, we'll call it as a torque. Here, it's a linear, so it's a push or thrust or a force. It's not rotation. So force or thrust, we're calling it like that. That's it. Because it's a linear induction motor, the name itself says. And the thrust, the force, depending on what? See, torque, what is torque equation? In case of rotational induction motor, can you quickly tell me in a rough way what is torque is proportional to? Torque is proportional to? Quickly tell me. Torque is proportional to? Torque is proportional to? Pg. Torque is proportional to Pg provided ns is constant, because torque is equal to 180 by 2 pi ns into Pg. This is what the torque equation. If ns is constant, then torque is proportional to Pg. So rotor input power is answer, but in the options, synchronous speed is also there. So both A, B are the answers. I mean, we have an option here which combines both A and B. Option C is the right answer. I hope you got the point. See, simple, lovely equation. This equation is enough. Okay, you have to have an idea of these particular simple things. If you have an idea of that, I know it'll work for you. Okay, got it? Will you tell me? Understood? Tap that. Good. Very good. Very good. Next question. Are you guys ready for the next question? I'm moving to the next question. If you're not ready, I can't do anything because I already moved to the next one. Try this. I think for this question, 2 minutes is pretty much high for this. 30 seconds, 20-second questions. And yes, we already got the answers from Raju and Ashrit and Praveen. Yeah, you guys are absolutely right. So the point is, what's the point here? It is said crawling. See, two aspects are there. What's the other aspect? What's the sibling? What's the friend of this crawling? There is one more term called, it starts with C in case of induction machines. What is that? What is that C? I mean, the other one which starts with C. Yes, absolutely, Ashrit. You're rocking. You're rocking. And I said, let's spin the wheel after this question. Let me explain this question. After that, let me just spin the wheel so that we'll see the first winner. We'll announce two winners in this session. First winner and second winner. We'll see who is the winner after this question. So crawling and cogging means what? What is cogging? Can somebody brief in the chat? What is cogging means? It is, yeah, in one word, if you had to say what is a cogging, how do you say? How do you define it? Yep, I'm waiting. I'm waiting. Cogging, Ishwar, we got D. Cogging is magnetic locking. It's a locking. Motor will not, there will be some torque produced, but motor will not be able to move it. It's not moving. It just locked. That's what cogging. Crawling means, babies will crawl. I mean, slow walk. I mean, it's not walk, crawling, right? Baby crawl. Means motor will run slowly. It has to run close to the synchronous speed, but it will not run close to synchronous speed. It will run close to zero speed. Okay. Rather, it will be running close to 1/7 of synchronous speed. Okay. So why is that happening? Because of the harmonic torques. And we have a video on this crawling and cogging effect on YouTube itself. You check that video, you'll get a good clarity on this cogging and crawling concept, and how to overcome these effects also will be pretty much clear. Okay. So answer is harmonics developed in the torque will lead to the cogging effect. Okay. Yes, guys, you're right. You're right. Interlocking, Sampath, you're absolutely right. Ashrit, you're right. Unable to rotate the rotor, you're right. And skewing, yes. Will skewing increase the starting torque or not? Yes, there will be a slight increase in the starting torque because of the skewing. Yes, definitely, it will be increasing, if I had to say. And Ishwar, yes, cogging effect. So, okay, so I want, let's see how many of you participated. Maybe, somebody not participating. I don't think everybody who is online, you're not going to get a chance to participate in the winning wheel, because you're just watching, you're not participating in the chat. So I don't think you'll be able to get a chance. Let me just spin the wheel and let's see who is the winner of the show. Okay. Yes, we got a big wheel. Let's spin the wheel. Let's spin the wheel. We just got 5 people. Okay, we just got 5 people. And I'm spinning the wheel. Yeah. Who is the winner? Yes. Go on. We are unable to see a Sampath. I think in the previous session also Sampath is a winner. This time also Sampath is a winner. It's kind of biasing me, but I don't know. It's not biasing or anything. It is actually saying Sampath is a winner. It is selecting Sampath all the time as a winner. It's not. I think Sampath, yes. You want it again, whatever the coupons will be providing, it's only for today. If you're contacting tomorrow for today's coupon, you will not get. Okay, contact Sampath kal gaya. Okay, yesterday also you're not contacted, it seems, so you lost it. So today, contact, you'll get some interesting coupon. Okay, for the PiSquare course. Will or lose, I will join. Okay, somebody saying win or lose, you're going to join. Yes, that's fine. It's just a funny game. It's not winning and losing. Lucky, right? If you're lucky enough, He'll get a chance to play, otherwise, But yeah, that's a sporty spirit. That's a sporty spirit. Whether you're winning or losing, you'll have to be on the game. Yeah. Okay. For Datri, give it a thumbs up because she's having, I think, nice sporty spirit. Okay, I think you tried good enough. I think we got a couple of answers. Somebody saying A, somebody saying B, somebody saying D. Okay, we got mixed answers here. Let's see who is right, who is wrong. Here, and we got some interesting question also in the back. They said they called from the interview room itself. Call was, I think there was similar question. There is an alternator and there is an induction motor. Both are mechanically coupled, and alternator is feeding. No, they're not mechanically coupled. Alternator is feeding electricity to motor. Then what is the speed of the rotor? Something like that. That was the question. Okay. Anyways, that to get to that question, if you understand this, you'll be able to answer those questions. So point of saying is, these questions are not just useful for maybe a written. If you understand the concept behind this could save your interview. Okay, and this will build the concept actually. Let's get into the question. What is said here? It is said power supply to a 10-pole induction motor. 10-pole induction motor is supplied by 4-pole alternator. Okay, we have a 4-pole alternator, 10-pole induction motor. Okay, power supply to 10-pole induction motor is supplied by 4-pole alternator, which is driven by 1500 rpm. Means alternator is driving the induction motor. It is giving the supply to the induction motor at what frequency? Tell me. It has 4 poles and 1500 rpm. So 50 hertz frequency is the supply frequency to the motor. Now you will ask a question, sir. How come? How come? Yes, they're not mechanically connected. They're electrically connected. Yes, right. Now you say, how come, sir, 50 hertz you're writing directly? Because as I said, ns is equal to 120 f by p is a formula. From there you can find out f is equal to pn by 120. Okay, but 50 hertz or f is equal to pn by 1, yeah. 4 pole and 1500 rpm means you have to keep that point in your head that it's a 50 hertz. 4 pole 1500 means 50 hertz. Okay, pair these three, because as an electrical engineer you should have these things in your head. Keep practicing it, it will be automatically injected. You don't have to remember it. Just keep a thought that yes, I have to remember this because it's a continuous one. Most of the times it is asked. So the frequency is 50 hertz. If the motor runs with a slip of 4%, okay, motor is running at a slip of 4%, means 0.04 is a slip. Then it is said what is the speed, nr, and a direct formula. Nr is equal to ns into 1 minus s. Ns, if you are giving 50 hertz frequency to a 10-pole induction motor, to a 10 pole induction motor, 120 into 50 by 10 pole. So you will get NS, you will get it as 600 RPM is a NS, because I'm giving that 50 hertz to this 10 pole induction motor. So synchronous speed of the motor is 600. So the rotor will rotate. Just apply that, without even applying, you can say, because it is involving some mathematics. But if you use some common sense, the speed of the motor will not be this. Okay, it will not be 600 because it will definitely be less than 600. So less than 600, you have two options. Out of those two, this is the right option. Okay, why I'm saying 576 is the right option, why I'm not saying 250 is the right answer? Because induction motor, it will be less than synchronous speed, the rotor speed, but close to synchronous speed. And tell me why we try to maintain close to synchronous speed. I already given in the previous lecture. Tell me why. Tell me why. Why it should run close to synchronous speed. If the speed and synchronous speed, the slip speed is high, then what's the problem? What's the problem? Yes, what's the problem? I'm looking for your answer, your explanation at least. What's the problem if the slip is high? The problem is the efficiency, copper losses will be high because EMF will be zero. No, it's not that. Slip copper losses of the rotor, copper losses are proportional to the slip. So copper losses are high, efficiency is poor. Okay, so that's why it should run close to synchronous speed. We'll try to design it like that. We'll try to have less slips. So answer is B for this, or else just simply plug the values here. 600 into 1 minus 0.04, you should be getting it as 576. Okay, I hope you got the point. Give it a thumbs up. Yeah. Yes. Next question. Let's move to the next question. We have less questions. We move to 2014 to 2015. We're at 2015 now. Okay. Let's see. Just a few more questions. That's it. We're going to end the session with next 3 more questions, I think. You answer this. Losses are high. You're absolutely right. This concept is again a simple concept, not so difficult one, simple one. That's why I ended it within 1 minute. Let me quickly explain. Just for the sake of time, I quickly find it up that 2 induction motors A and B, they're identical, means they're just the same. They are twins, except A is having larger air gap. See, when they are giving in the question something like this, you have to be clear with the terminology what he's trying to ask. He said clearly A is 50% greater than, means air gap of A is 50% more than 50% more. You write that explicitly, otherwise you'll be confused. So if air gap is more, then it will draw more to maintain the same flux. It has to draw more magnetizing current. It has to draw more magnetizing current. It is drawing more magnetizing current. Magnetizing current is lagging in nature. So it is drawing more lagging current, means poor power factor. Which one? A or B? The one with larger air gap. Okay, so A is having larger air gap, so the no load power factor of A will be compared to the B. Okay, Usually compared to the transformer, induction motor will have more lagging power factor because, poor power factor because of the air gap only. The presence of air gap is there in case of induction, but transformer has no air gap. Hence, it has a better power factor, no load power factor, Okay, yes, Sampath, you're right. Let's move to the next question. I hope you're getting the points. We are having 4 more questions, I think. With that, we'll be ending the session. Try this out. Simple one. We got some answers, but they're not totally right. Let's see what's the right answer. See, concept, if you understand, I don't think you should be doing a mistake on this because this is a basic fundamental question. If you're doing mistake on these questions, also means what? You don't have enough idea of what's happening with the induction motor. Okay, this is a basic level question, not a tough level question. Okay, so for these questions, if you have a basic understanding of induction motor, you should not commit mistake. Anyways, let's see this. Induction motor is drawing active power as well as reactive power from the grid. P and Q, it is drawing, it is taken. Okay, now if the same induction motor is operating as a generator, what will happen to P and Q? Motor means taking, generator means giving. So you think that both will be positive. You'll think that. See, it is motor is taking means I'm taking it as a positive. Motor is taking means motor is taking. You'll normally do this, but this is not exactly right. Understand the terminology. Motor is taking, it is positive. But if the same motor is giving, then you should treat it as a negative. Okay. So, what is, induction motor? Let me just clearly write here for the sake of clarity. Induction generator, induction motor. P and Q. In case of induction motor, it will take P and it will take Q. It will absorb both P and Q. Okay. Now if it is induction generator, it will give, generator job is to deliver the power. Which power? Active power. Active power delivered. Okay. If it is induction generator, it will give the active power, but induction machine needs some reactive power to produce the flux. Okay, it will still take the reactive power. Okay, I'm taking this one as positive here, positive here. So this is same, so positive, this is reverse, so this will be negative. So P will be negative, Q will be still positive. In case of synchronous machine or synchronous generator, alternator will give the active power for sure, but reactive power, it may take from the source or it may give to the source. Why? Because on the rotor side, you have an opportunity, you have a scope to deliver or give the flux. There is a scope for you to give the flux because rotor is excited by a separately excited DC source. Okay, you have a scope to give it. Okay, anyways, so I hope you got the point. I'm moving to the next question. Shall we? Shall we? Click that thumbs up. Beyond resonance is saying E, option E, good. Option D, he wanted to try B, maybe he tried, he just pressed E, I think. Next question, yes, you're right, beyond resonance. Get ready for the wheel, spinning the wheel, we'll spin the wheel once again. We're at the last. Two more questions are left. I think this question is easy one. Let's not take much of time for this because I already discussed this question in the previous parts also. It says the starting torque of a three-phase induction motor can be increased by increasing the rotor resistance. Rotor resistance, higher the rotor resistance, higher the starting torque. That's the beauty of slip ring induction motor. I have already extensively explained about this. Next one. Careful guys, don't just guess and give the value. Just try it once. Try it, then you'll get a clarity on what is right, what is wrong. Raju, just think a little more. Think once again. Ishwar, everyone who is opting, just give once again thought. The 5 means 5 square is 25. Don't do that kind of mistake. Okay, it's not 5 times. It's not 5 times. If it is 5 times, then 5 square times is a change. It's a 5%. Careful. Here, if you see, change in 5% of supply voltage means first case 100% if you take. The change is maybe 100 volts, let's take it. So new voltage is maybe 95 volts. Maybe 95 volts. That's what 5% change. Okay. So for 100 volts, you got 100% of the torque. Okay. So means 10,000, 100 square is 10,000. Let's take 10,000 Newton meter. I have already discussed that in the previous part. 10,000 Newton meter. Let me take this one as 100%. So 95 square, how much, tell me? 95 square, if you do it, you'll get 9025 Newton meter. Just a rough number. Means percentage wise 90.25%. So if the change in voltage is 5%, change in torque is how much percent? From 100 to 90.25. Almost 10%. Okay, almost 10%. Now, it is not said decrease in voltage. It is said just simply change in voltage by 5%. Means it could be increase also. Just take that possibility also. Means earlier it was 100, now it is 105. If this is the case, then what is the value? Its corresponding value is, I'm just having it, okay, 11025. You just square it. 105 square is 11025, I'm not wrong. Okay, so if this is 100%, this is 110.25%. So both the cases, just look at these lovely cases. In these two cases, here 5% less, here 5% more in the voltage, but both the cases, percentage change in the torque is almost 10%. So The answer is D. 10% of the rotor torque will be the effect. I hope you got the point. Okay, if you got the point, give that thumbs up. That heart, pump something into that heart. Pump something into that heart. Okay, good. Okay, I hope you got the logic. Anyways, let me move to the next question then. I think this question already we have seen in the first part. Okay, so let me not spend much of time in answering this because same question, 2013, same question is asked. Now 2017 also same question is asked. Okay, so the answer is the change. We did all the analysis. Okay, and I think Raju was saying 123% or something maybe. Okay, so but it is 23% is an increase in the copper losses. Okay, so that's it. That's end of this particular lecture. Okay, we completed almost all the planned questions in this. I'll continue with this in the next 2018, 19, 20, all these questions. And before we wind up, let's see the winner again. Okay, who will be the winner of this second winner? Okay, let's see who will be. Now we got one more person, I think, joined in this wheel. That's what, in this wheel, people will get to play this or, have its opportunity to have a name on this based on your chat. If you're chatting good, I mean, you're responding good in the chat. So obviously, so let's spin it. Whoa. Who is the winner? My goodness, what's happening here? So again, Sampath. I'll have to check with my team maybe. How come every time it's speaking Sampath is lucky enough to be here or I mean get the chance or he's responding good? I'm not sure, but yeah, there is something. I'll have to check with the team, I think. Because yes, Sampath, it's not just you, even I'm also huh, okay, even my guys also will have to check it. Okay. Anyways, so Sampath, good. Let me just end this session. Okay. So nice. Anyways, everybody has good participation. See you in the next lecture.